NanoFarfield is a far-field antenna measurement system, compatible with a wide range of VNAs, measuring frequencies up to 6 GHz. The NanoFarfield software drives the motor, reads your VNA, and takes you from setup to a full radiation pattern in one guided workflow, with 2 modes built on the same engine: Basic Mode and Advanced Mode. Basic Mode walks you through 8 clear steps. Only the current step is active, so you always know exactly what to do next. Every step has a quick guide. Click the question mark and you get a short how-to for exactly what that step needs. Now, pick your VNA model, click a port to connect. The same for your motor controller. Green means you're ready. After clicking Confirm, you will see it redirected to the Scan Setup section. 2 ways to measure. Antenna gain measurement, which is what we're using here, gives you an absolute gain value using a reference antenna with a known gain. Normalized radiation pattern shows you just the shape of the pattern, normalized to its peak without a reference antenna. For the scan itself, full scan covers the complete 0 to 360 degrees. Partial scan lets you set your own start and stop angle if you only need part of the rotation, and step sets how many degrees the antenna moves between each reading. Confirm locks in your angles and takes you to frequency setup. Set your frequency sweep, a start and stop frequency in megahertz, and how many points to measure across that range. The step size between each point is calculated for you. 1 click on check runs a live sweep, confirming your VNA is reading correctly. Then Confirm takes you to mounting your reference antenna. First, line up these 2 triangle marks that sets your 0-degree reference, so the antenna always sits in the same known position on the mount. NanoFarfield ships with 2 reference antennas. One mounts to the large flange, the other to the small flange. Pick the one that matches your setup and mount it here. Once it's mounted, click I'm ready to move on to reference setup. This step needs exactly one choice. Pick just one of these 3 options. Use predefined antenna is for when you mounted one of the reference antennas that shipped with your system in the last step. Find that same model in this list and select it. The software runs the reference measurement for you automatically and saves it. Create a new reference is for when you mounted your own antenna in the last step instead, one whose gain values you already know. Here you type in that antenna's known gain in dB at every frequency you're measuring. Then click Get Values, and the software measures the actual signal level at each of those frequencies for you. Together, the gain you typed and the signal level it measured become your reference. And load reference file is for when you've already measured a reference before and saved it. As long as that saved file covers every frequency in this measurement, you can just load it and skip measuring a new one. Whichever one you use, you'll see it confirmed right here as selected file. For this measurement, we'll go with Use Predefined Antenna. We select it from the list, pick the file matching the antenna we actually mounted, and the measurement is taken and saved automatically. Whichever you choose, Confirm is what checks it. It makes sure your reference actually has data for every single frequency you're about to measure. If even one frequency is missing, it'll tell you before you can move on. Now it's time to mount the antenna under test. Remove the reference antenna, attach the flange that fits the antenna you're about to mount. Then mount your antenna under test in its place, and don't forget to connect your connector. Click I'm ready to move on to measure antenna under test. If everything is set, you can start the measurement by clicking Start. A few seconds later, you'll see the system begin to move. From here, watch the motor do the rest: live angle, live timer, and a clear estimate of how long you have left. A few seconds later, the turntable begins to rotate, carrying the antenna to its first measurement angle. From here, the whole process runs on its own. The system moves into position, takes its reading, and steps to the next angle, without you touching a thing. When the scan is complete, the motor performs a homing move. It returns to its 0-degree home position, and the measurement is done. You're taken straight to results. And you're done. Click View Results to see your measurement. Every frequency you measured gets its own tab, with the radiation pattern plotted right there, along with your peak gain, direction, and beam width. Click anywhere on the pattern to drop a marker. It snaps to the nearest measured point, so you can drag it around and read off the exact value at each angle. You can also set your own min, max, and ticks to rescale the chart. And if you'd rather view it as Cartesian, just click Switch to Cartesian, all the same adjustments you just made. Markers, rescaling, everything work exactly the same way here too. Back on this screen, Export Data saves your raw measurement to Excel, and New Measurement takes you back to the start for your next one. And that's basic mode, start to finish. One click switches you over to advanced mode, same connection, same settings, carried right over. Here, we'll click through everything. Advanced mode keeps your setup panel on the left, your results in the center, and a live output console on the right, all visible on screen together. On the left, there are 3 main sections. Measurement setup is where you do everything to get a scan running. Device, scan setup, frequency setup, reference setup, and start measurement all live here. Analysis is where you review and process your results afterward. An instrument is for direct hardware control. Connecting works the same as basic, pick your model, click a port for the VNA, click a port for the controller, then confirm. Unlike basic though, you are not locked into order here. You can open any section of this list whenever you want. Scan setup works the same as basic. Advanced adds one more thing, manual positioning. You can move the antenna to any angle you want with Move and watch the live signal with Monitor. Let's open Monitor first. You've got 2 view options here. One channel keeps things simple with a single plot, while 2 channel shows magnitude and phase side by side. And within one channel, you can switch between watching just the magnitude or just the phase. Set your frequency range, points, and how many sweeps to average if you'd already filled in frequency setup. Those values would show up here automatically too. Click See Spectrum, and the plot starts updating live as the VNA keeps sweeping. Over on the right, the output panel logs everything as it comes in. Click Stop whenever you're done, then see Spectrum again to pick right back up, this time watching phase, so you can see how the signal behaves across your frequency range. Stop again when you're ready to move on. Type another target angle and click Move again, same thing, any angle, anytime. Then open Monitor once more, it's still sitting right where you left it, and take another look, this time with a different number of points, back on magnitude. Once you're happy with what you see, close it out. Homing sends the antenna back to 0 whenever you need it, and Confirm locks in your angle list, same as before. With scan setup confirmed, we move on to frequency setup. Unlike basic mode, here you'll find Measure Noise Floor. Before measuring noise floor, you can use Check to see the current signal levels directly. Then disconnect the antenna. Click Measure Noise Floor. The software averages a few sweeps with nothing connected and stores that as your baseline. Then, reconnect the antenna. Click Check. And now every frequency reading comes with its signal-to-noise ratio, so you know exactly how clean your measurement is before running a full scan. Confirm locks it in. Reference setup works exactly like basic load-a-saved reference. Pick one from the library or measure a new one on the spot, then confirm. Start the run in its own window. On the left, its own console streams everything live, which angle the motor just reached, and the exact frequency, magnitude, and phase at every point it measures. On the right, a live polar plot tracks your first frequency in real time, building the pattern point by point as the antenna sweeps around. Pause at any time and resume right where you left off. Up top, measured angle and elapsed keep you posted on progress, and the status dot tells you at a glance whether it's running, paused, or done. If you ever need to cut a run short, click Stop. It finishes the motor's current move, sends it back to its starting position, and the measurement ends there. Save writes out your results, exactly like export. There's also a monitor button right here too, same live spectrum view as before, so you don't have to leave this window to double-check your signal before you start, or between runs. Now let's start it again, and this time let it run all the way through, and once it's done, let's see what we've got. As soon as the measurement finishes, your results land right here in the table automatically. Click View Plot, and it opens the exact same window you saw in basic mode, same polar plot, same markers, same everything. Close it, and click Export to save your results to Excel. For deeper analysis, there's plot options. Switch between frequencies right here with the drop-down. Toggle between polar and Cartesian to see the pattern either way, and between magnitude and phase to see either quantity. You can change the min, max, and ticks to rescale the chart exactly how you want it. Click anywhere on the pattern to drop a marker. It snaps to the nearest measured point, so you can drag it around and read off the exact value. And when you're ready to share what you found, Save All to PDF turns every frequency into one PDF file. Clear Markers wipes them all off in one click so you can start fresh. Under Instrument, Hardware is where you tune the motor. Starting from the top, azimuth motor limits set how far the axis can physically travel. Frequency limits cap what you can enter elsewhere, pre-filled from your VNA. Then hardware speed settings, maximum speed is the top speed the axis reaches once it's moving, and acceleration is how quickly it ramps up to that speed and eases back down. Let's try an example. We'll drop maximum speed from 2000 down to 1000, and acceleration from 1000 down to 500. Then click Apply. You can see the difference immediately. The motor moves noticeably slower now. As a rule of thumb, it's best to keep acceleration at around half of maximum speed, high enough to get moving efficiently, but gentle enough not to strain the mechanics. Back up in motor parameters, move speed and home speed scale that same maximum speed down as a percentage, one for your actual scan moves, the other for homing. And scan speed reduction is a bit different. It's not about how fast the motor moves. It's about how long it pauses once it arrives. Every time the antenna reaches an angle during a scan, this is the extra delay, in milliseconds, before it moves on to the next one, giving any vibration from that last move, or your VNA, a moment to settle before the reading is taken. Now let's take a look at OpenFile. It brings a saved measurement straight back into the table. You don't have to rerun a scan just to look at old data. Let's load one we took earlier and use it to walk through time gating. Time gating is for cleaning up reflections, echoes bouncing off walls, cables, or anything near your setup that distorts the measurement. The software converts your frequency sweep into the time domain, where the direct signal from the antenna arrives as one clear peak, and any reflection shows up later in time. You define a gate, a time window around that main peak, and everything outside it gets cut out before the software converts back to the frequency domain. The time domain plot bottom left is where you actually see and set the gate around your peak. Frequency domain, top left, compares your raw signal against the gated result, and the pattern on the right recalculates live. Using only the gated data, the sliders let you step through every angle and frequency you measured. Below the sliders, frequency filter lets you narrow the whole analysis down to just part of your measured band. Type a new start and end. Click Apply, and everything recalculates for just that range. Pattern Options controls how the pattern on the right looks, polar or Cartesian, S21 or gain if you've got a reference loaded, and amplitude or phase. Pattern Limits sets your own min, max, and tick spacing for that same chart. And down at the bottom, 4 ways to save what you're looking at: save FD gated data and save TD gated. Data export the gated frequency domain or time domain numbers to Excel. Save current saves just the chart you're looking at right now. And save all to PDF renders every frequency into one file. Let's go through the 3 gate modes properly. Getting this right matters a lot for how accurate your results are. Manual gate is the simplest. You type the exact gate start and gate end in nanoseconds. No automatic detection. Whatever you type is exactly the window that gets applied. Full control, but you need a rough idea of where your peak already is. Auto gate. Give it a search start, search end, and a half width, and it finds the peak in that range and centers the gate around it for you. Right now, it's tied to the theta slider. Move to a different angle, and it refines the peak there and recalculates the whole pattern with that new gate. That's actually handy for exploring where the gate lands before you settle on one. Click Lock Gate, and whatever gate was just found at your current angle gets frozen and applied to every angle from here on. The slider no longer moves it. That works well when your antenna is well centered on the rotation axis, since the direct signal tends to arrive at roughly the same time no matter which way it's pointing. With Lock Gate, remember, every angle reuses that one gate found at a single angle. Dynamic Gate does away with that. Every angle finds its own peak and gets its own gate independently, nothing shared. That's why in dynamic mode, the pattern doesn't shift when you drag through angles. Each one's already been gated on its own. Use it when the direct path genuinely shifts in time as the antenna rotates, so a single fixed gate wouldn't line up for every angle. One more thing before we move on: window types. Rectangular gating means every time point in your gate gets multiplied by 1. Hamming, Hanning, and Blackman each multiply your time points by a different set of coefficients instead. That's what shapes the taper you see here. Raw stays on screen in gray, dashed as your unweighted original. You can turn on more than one window at once, each colored differently in every plot. So you can compare them side by side and pick whichever gives you the cleanest result for your setup. And that's NanoFarfield, start to finish. If you have any questions, you can email support@antenite.com or reach us through antenite.com.